Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular paper is AQA November 2022, paper 3, higher tier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I've recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends because they might need a helping hand too. Okay, let's get into it. Question 1. 2 to the power of x equals 32, circle the power of x. Well, I know 2 to the power 1 is just 2, isn't it? And then 2 squared is 4, and then 2 cubed is 4 times 2 is 8. So 2 to the 4 is 16, and 2 to the 5 is 32 then, isn't it? So then that x up there must be the same thing as that 5 down there. So x is equal to 5. Question 2. What is 1.8 times 10 to the minus 4? As an ordinary number, circle your answer. So numbers in standard form with negative indices like this, these tend to be very small numbers, don't they? So this is the mantissa part, 1.8, and then we've got a power of 10 to the minus 4. And the kind of way I remember this is that I write, if it's powered minus 4, I write 4 zeros, 0.000, 1, 2, 3, 4. And then once I've written down my 4 zeros, I then write the mantissa part, the 1 and the 8, like that. Okay, so negative 4 means 4 zeros. Don't forget to put the decimal point in, and then we write the mantissa of 1, 8. So that is the same as that one. Question 3. Expand 6x squared, lots of x cubed plus 2. Circle your answer. Okay, so when we've got a single bracket like this, whatever's sitting on the outside of the bracket there gets multiplied by everything inside the bracket. So first off, I'm going to multiply 6x squared with x cubed. That's going to give me 6x to the power of 5. And then when I multiply 6x squared by 2, I'm going to get 12x squared. So which one is that? It must be that one there. Question 4. X lies between 30 and 300. X is 200% of y. Circle the correct inequality. Okay, so if x is 200% of y, then y is going to be smaller than x, isn't it? It's going to be half as big. Whatever y is, x is double it. So whatever x is, y is half it then. So if I've got 30 is less than x, which is less than 300, and I divide everything by 2, I'm going to get 15 is less than y, which is less than 150. Which is that one there, isn't it? Question 5. A, B, C, D, E is a pentagon. Yes, it is. Work out the area of the pentagon. Well, you can consider this pentagon to be made up of two shapes. You've got like a trapezium part here, which I know how to work out the area of. And I've got a triangular part here. It's a right angle triangle, so I should be able to work out the area of that too. Okay, so I'm going to call this one area 1. And I'm going to call this one area 2. I'm going to work them out separately and then I'm going to combine them together to find the total area. Okay, so area 1 first up, that is a trapezium, and the formula for trapezium is a half open brackets, a plus b times h, where a and b are two parallel sides and h is the distance between them. So in this diagram, a is going to be 14, and b is going to be the side parallel to that. It's going to be that one there, 20. And then h is going to be the distance between them, so it's that one there, the 11. Okay, so subbing that into the calculation or into the formula, I've got a1 equals a half a, which is 14, plus b, which is 20, times h, which is 11. Basically, when you're doing this, you're kind of averaging out your two parallel sides, aren't you? Add them together and divide by 2. So what's the average for your two parallel sides? What's the average of 14 and 20? Well, 14 plus 20 is 34, divided by 2, and they average out to be 17. So you can average out the two sides to be 17, and therefore the area is just 17 lots of 11. So what's 17 11s? Well, 10 17s is 170, so 11 17s is going to be 187. Okay, so that's A1 done. That's the trapezium. Okay, so let's move swiftly on. Let's have a look at A2, the blue one. Now A2 is a triangle, and the formula for the area of a triangle is just half base times height, where base and height, they don't necessarily have to be the bottom line and the one going up. They're just the two lines that are perpendicular to each other. So in this case, it's going to be 7 and 10, isn't it? So it's going to be half times 7 times 10. Half of 10 is 5. 5 times 7 is 35. So area 2 is 35. So then the area of the pentagon is going to be area 1 plus area 2, which is 187 plus 35. What's that then? 187 plus 35, 192, 222. 222, what's the units? Centimeters squared, isn't it? Okay. 222 centimeters squared. Question 6. Joe, Kim and Lisa each have an amount of money. Joe has £72. Joe's amount to Kim's amount is in the ratio of 6 to 5. Lisa's amount is 1.5 times Joe's amount. Show that in total they have less than £250. Okay? So we know Joe is 72, and we also know everybody else is relative to Joe's, because Joe's amount to Kim's amount is in the ratio of 6 to 5. Okay, so let's start with that one then. So Joe to Kim is in the ratio of 6 to 5, but we know that Joe is 72, okay, which is how many times bigger than 6? 6 goes into 72 12 times. So if I times that up by 12, I get 72. So if I times this one up by 12, 12 lots of 5, that's equal to 60. So I make Kim's amount then equal to 60. Okay, and then Lisa's amount is 1.5 times Joe's amount. So what is Lisa's amount then? So this was for Kim, and now we're on to Lisa. So Lisa is going to be Joe's amount, which is 72, times 1.5, isn't it? Okay, so 1.5 lots of 72, you could type it into the calculator, but it's just 1 lot of 72 plus half of 72. So half of 72 is 36. Add it on to 72, that's 108 then, isn't it? So Lisa's is 108. So altogether then, Joe's plus Kim's plus Lisa's is going to be 72 for Joe, plus 60 for Kim, plus 108 for Lisa. What does that come to? That's 168, 170, 240 then, isn't it? So they add up to 240, which is less than 250, isn't it? So total is less than 250. Okay, so we've kind of done it. Question 7a. Here is the rule for a sequence. After the first two terms, each term is the sum of the previous two terms. Okay, so it's a little bit like a Fibonacci sequence. The first term is 33, the second term is x, the fourth term is 73. Work out the value of x. Okay, so we know that u1 is 33, and we know that u2 is x. So then u3 is going to have to be the sum of those two then, isn't it? It's going to have to be 33 plus x. And then u4 is going to have to be the sum of u2 and u3. So it's going to have to be x plus 33 plus x. In other words, it's 2x plus 33. Okay, but we've actually been given the value of the fourth term in the question. We've been told it is equal to 73. So this expression over here, u4, has to be equal to 73. So that means we can form an equation in x that we can then go on to solve then, can't we? So if I know that 2x plus 33 is equal to 73, then I can just solve for x, taking 33 away from both sides. Minus 33 minus 33. They'll cancel, just leaving me with 2x. And then 73 take away 33 is 40. So then dividing both sides by 2 then. It's going to give me 2x divided by 2 is x. And 40 divided by 2 is 20. So that's my answer then. X is equal to 20. Question 7b. An expression for the nth term of a different sequence is n minus n squared. Ruth says all of the terms will be negative because n squared is always greater than n. Is she correct? Tick a box. Well, she's almost always correct, apart from when n is 1, I guess. So she's not always right, because when n equals 0, then n minus n squared is going to be 0 minus 0 squared, which is equal to 0. And I don't think 0 counts as a negative number. 0 is not negative. Okay, it's a kind of in between, isn't it? 0, it's neither positive nor negative. Okay, so not negative. Question 8. Here is some information about members of clubs A and B. Club A, number of members is 24 and the mean height of the members is 1.8. Club B is a club for giants. There are 20 of those and the mean height is 1.92 meters. Work out the total height of members in Club A divided by the total height in members of Club B. Give your answer as a decimal. Okay. Well, the total height then we can easily get by multiplying those two together then, can't we? So if I take the number of members, 24, and multiply it by the height of 1.8, I'm going to get the total height for Club A and similarly for Club B. So what is 24 times 1.8? 24 times 1.8, that comes to 43.2. 43.2. And the 20 members of Club B with a height of 1.92 comes to 38.4. Okay, so then the total height of members of Club A, 43.2, divided by the total height of members of Club B, 38.4. What's that then? So 43.2 divided by 38.4. That comes to 9 over 8, which is 1.125 as a decimal, 1.125. Question 9. P and Q are points. The x-coordinate of Q is 4 more than the x-coordinate of P. The y-coordinate of Q is 5 less than the y-coordinate of P. Work out the gradient of the straight line through P and Q. Okay. Now let's create a general point P which has got coordinates x and y. So if that's my point there, then I know that Q is 4 more than P in the x direction. So it's going to be like 4 units in that direction, isn't it, away from P. And its y coordinate is 5 less than the y coordinate of P. So I'd have to be going down 5 to get to Q. So Q is going to be down here somewhere, isn't it? So that's going to be Q with x coordinate x plus 4 because it's 4 more than P, and y coordinate y minus 5. Okay, I don't really need that actually. I can just use the triangle actually to solve this, can't I? So if you think about it, we want the gradient of this line here, and gradient m is equal to change in y divided by change in x, isn't it? Okay, so here change in y is 5 and change in x is 4. Don't forget though that this line is sloping downwards from left to right. So you could consider that to be -5 rather than +5. So this gradient is going to be negative overall. So it's going to be -5/4. Question 10. Here are the results after 250 spins of a coin. Now it landed on heads 128 times and it landed on tails 122 times. The coin is spun an extra 50 times. After all 300 spins, the relative frequency of heads is 0.49. For the extra 50 spins, work out the number of heads to the number of tails. Okay. So overall, the relative frequency of heads was 0.49. So then the number of heads in total that were achieved is going to be the 300 trials times the relative frequency of success. It's going to be 300 times 0.49. That's basically going to be 3 lots of 49, isn't it? It's going to be 147. So 147 heads altogether. So there are 147 heads altogether. So the number of new heads is going to be the number of heads altogether minus the number of old heads, which was 128. What's the difference then? So there must have been another 19 heads then in the last 50 trials then. So then the number of heads to tails then in the last 50 in final 50, heads to tails is going to be, well, they're going to be 19 heads, and then how many tails is that then? So the rest of it would be tails, so it's going to be 50 minus 19, and that's going to be 31 tails. Okay, so I had a bit of a run of good luck on tails in the last 50 then. Okay, so 19 heads altogether and 31 tails in the final 50. Question 11. Part of a running track is the arc of a semicircle joined to a straight line. The semicircle has a diameter of 45 meters. The straight line has a length of 75 meters. Abby runs once along this part of the track in 18 seconds. Work out her average speed. Give your answer to 2 significant figures. Okay. Now, we know average speed, well, we should know average speed from the DST triangle, DST. If I want to work out speed, then it's going to be distance traveled divided by time taken. So average speed equals distance traveled divided by time taken. Okay? So do we know any of those things? Well, we know the time. We know t is equal to, so we can sub 18 in straight away, and that's the time taken, and isn't it? T is equal to 18. Okay, but what about the distance traveled? We don't know that yet, do we? So we need to work out what that distance is before we can work out the average speed. Okay, now the distance traveled is going to be a combination of this part of the track, okay, which is an arc, plus this part of the track then, isn't it, which is a straight line. Okay, well, the straight line is easy, it's 75. What is the curved part going to be? Well, it's half of the circumference of that circle. Now we know that the diameter of the circle is 45, and I know that the circumference of a circle is pi times its diameter. Okay, but we've got a semicircle, so our arc length is going to be half of that, then isn't it? It's going to be pi times diameter over 2, because it's half of a circle. Okay, so we know that the diameter is 45, so it's going to be 45 pi over 2. So that's the arc length, and so then the total distance traveled is going to be the arc, which is 45 pi over 2. I'm just leaving it in terms of pi for now, just to maintain accuracy, plus the straight section, which is 75. Okay, so this is the curved part, and this is the straight part, and altogether that is going to give me the distance. Okay, so then the distance traveled then is going to be whatever that is divided by 18. Okay, so I'm just going to work out what that is now then. So what is 45 pi over 2 plus 75? So 45 pi divided by 2 plus 75. That comes to 145. I'm just going to round it off to 145.7. 145.7. And so I'm going to then divide that distance then at that 145.7 needs to go in here then, doesn't it? 145.7, that's what I'm going to be dividing by 18. Now, it wasn't quite 145.7. I've got the full amount on my calculator, and that's actually the amount I'm going to use. I'm not going to divide 145.7 by 18. I'm just going to take my last calculated value, which is the big long decimal, and divide that by 18 to retain accuracy as I go along. Otherwise, your answer kind of diverges from the true answer if you keep rounding off mid-calculation. Okay, right, so that comes out to be 8.0936. Now I need to round this off to two significant figures, so that is equal to, I'm going to have to round off after the 0. Next digit is 9, which means I round up, so it's going to be 8.1 to two significant figures then, isn't it? Okay. Question 12, triangles A, B, C and D, E, F are shown on a grid. Describe a single transformation that shows the triangles are congruent. Okay, well these look to me like a translation. It's being translated, isn't it? If you think about it, if I look at the vector from A to D, this line here, look. Now that line there, if I picked it up and move it, you can probably see it's the same as the vector from B to E, and it's the same from the vector from C to F. Okay, so it's all the same distance between those matching points. So it's clearly a translation. Okay, and all we need to then do to describe that translation is to work out what that column vector is. So this column vector goes this far in the direction of X, and this far in the direction of Y, isn't it? Just kind of triangulating that vector in the direction of X and Y. So how many squares is it in the direction of X? It's like 1, 2, 3, 4, 5, 6 in that direction. So that's 6, and going up it's 1, 2, 3, 4, isn't it? So it's got a height of 4. So then that as a translation vector, it would be a translation using vector, right, distance in the direction of X, which is 6, distance in the direction of Y, which is 4. So translation using vector 6 over 4, like that. Okay, that's my answer. Question 13. A fair ordinary dice is rolled and a counter is taken at random from a bag. The tree diagram shows the probabilities. Okay. So the first part of my tree diagram is the roll of the dice, and you can see here that they're looking at the probability that it's either even or not even. You've got 3 even numbers on the dice, 2, 4, and 6, and 3 not even numbers, 1, 3, 5. So the probability of rolling an even number is going to be 3 out of 6, which is the same thing as 0.5, and same for odd number. Okay, and then for the counter part, we've got red, blue, and green. So clearly we've got more greens than blues and reds. We don't know how many counters are in the bag, but we know the probability of drawing a red is 0.1, which means 1 out of every 10 of the counters in the bag must be red. 0.3 means 3 out of 10 of the counters in the bag must be blue. And 0.6 means that 6 out of 10 of the counters in the bag must be green. So how do the probabilities show that all the counters in the bag are red, blue, or green? Well, you can show that that must be all the answers, because these numbers add up to 1, don't they? Okay, so the probability of red plus the probability of blue plus the probability of green equals 0.1 plus 0.3 plus 0.6, which adds up to 1. So, which is certainty, isn't it? Certainty. Okay, therefore all the counters must be red, blue, or green. Okay, circle the probability that the counter is red or blue. So the probability that the counter is red or blue That's going to be the probability of it being red plus the probability it being blue, because in probability or means add, and it's normally and means multiply. Okay, so basically if you can phrase your probability with the word or in it, it tends to be added, and if you can phrase it with an and in it, it tends to be multiplied. Okay, so in this case I'm going to be adding these probabilities together. So probability of red was 0.1 and the probability of blue is 0.3. So adding those together, I'm going to get 0.4. It's going to be that one there. Okay. Circle the probability that a dice lands on an even number and the counter is blue. Okay, so we said earlier that or means add. Okay, so but we also said that and is multiply. Okay, and here we've got an and. So what we want to do is work out the probability of an even and blue. Even and blue. So that's going to be the probability of even multiplied by the probability of blue. Okay, basically we are going down the even blue route there, aren't we? We're just multiplying everything we get going along. So the probability of even is 0.5, the probability of blue is 0.3. 0.5 times 0.3, that's 0.15, isn't it? So it's going to be that one there. Question 14. Here are two solid cubes, x and y. The mass of x is 10.976. The area of each face of x is 784 centimeters squared. And we've got part A. Zane wants to know the density of y. He assumes that y is identical to x. What densities should he get for y? Give your answer in grams per cubic centimeter. So if y is identical to x, then if we work out the density of x, it should be the same thing as the density of y, shouldn't it? Okay, because they're identical, or that's the assumption. We're assuming that they're identical. So if we assume they're identical, then we assume that the densities are the same for the two. So if I work out the density of x, it should be the density of y. Okay, now density is equal to mass divided by volume. Do we know density? There's a little triangle for this, isn't there? So density, mass and volume go like that. So what do we know here? We want to find the density. Do we know the mass? Yes, we got the mass. The mass was given up here, wasn't it? So mass is 10.976. 10.976. The volume, do we know the volume? Well, we don't yet, but we know some things about this cube, don't we? We know the area of this face here. Each face has an area of 784. So this here, this face here, has got an area of 784, isn't it? Okay, so then what is the length of this this cube? Well, all the lengths are the same. So if I take the square root of 784, root 784, what's that equal to? So calculator, what is the square root of 784? Calculator says it's 28, Tony. Okay, so that is 28. So that means that's 28, but also the other two dimensions of the cube are 28. So then the volume is going to be 28 cubed then, isn't it? 28 times 28 times 28. So what's 28 cubed? 28 to the power of 3. That's 21952. 21952. Okay, so now we know the mass and we know the volume, so we can sub those into our formula for finding density then. So density is going to be 10.976 divided by 21,952. So what's that, calculator? 10.976 divided by 21,952. That comes out to be 0.0004. It's 5 times 10 to the minus 4. So that's equal to 0.0005 then, isn't it? But remember, that's in kilograms per cubic centimeter. Now looky here, it says the answer needs to be in grams per cubic centimetre. So how can I convert that into grams per cubic centimetre? Well, I know that 1 kilogram is 1,000 grams. So if I take that answer and I multiply it by 1,000 times 1,000, I'm going to get a half, or 0.5 then, aren't I? So that's equal to 0.5 grams per cubic centimetre. Question 14b. In fact, the mass of y is less than the mass of x, and the area of each face of y is greater than the area of each face of x. What does this mean about the actual density of y? Tick one box. It is less than your answer to part A, is equal to the answer of part A, is greater than the answer of part A, is not possible to tell. Okay. Now remember, the calculation that we used was density is equal to mass divided by volume. And now, how do these changes affect this formula? So the mass of y is actually less than the mass of x. So we used a greater value than we should have done in this one. So actually, this one is going to become smaller. So the mass is going to become a smaller number. What about the next part? So the area of each face of y is greater than the area of each face of x. So what does that mean? So remember, what we did here is we took the area, didn't we? We square rooted it to find x, and then once we knew x, then we cubed it to find the volume then, didn't we? So what we're saying is that because whatever this area is here is bigger, when I square root it, this is going to be bigger, and when I cube it, this is going to be bigger. So in other words, the volume is going to be bigger. Okay? So in my calculation, I'm taking a smaller number and I'm dividing it by a bigger number. Okay? What's that going to do to the density? Well, the mass being smaller is going to make the density smaller. The volume being larger is also going to make the density smaller, because when you divide through by a larger number, you get a smaller amount. So both of those acts in the same direction. It means that density is going to go down and density is going to go down. Okay, so they're the two effects of those things. So any way we squeeze it, the answer that we got in part A is going to be greater than the actual answer. So that means the density of y is going to be less than the value it was in part A then, isn't it? Because we're saying the density goes down. So our density of y is going to be less than the answer we got for part A. Question 15. A mobile phone takes 2 hours to charge from empty. When the phone is being charged, the current flow into the phone starts at a full current flow of 100%, continues at full current flow for the period of time, and then it gradually decreases until the phone is fully charged. And we can see that going on here, can't we? So it starts on full current flow of 100% here, and then continues at a full current flow for a period of time, and then gradually decreases when the phone is fully until the phone is fully charged. So this is the bit where it's gradually decreasing then, isn't it? Okay, and then graph B shows the percentage charge of the phone when charging from empty. Okay, so again, this straight section here is going to correspond to the flat section on graph A, and then this tapering off part here is going to match the tapering off part in graph A then, I guess. That's kind of how it's going to go. So Megan's phone is empty on charge. She starts to charge her phone at 10 a.m. Using graph A, estimate the time when the current flow starts to decrease. So it's going to decrease at this point here then, isn't it? Whatever that is. So we'll just drop a line down to the axes there. What's that then? What value is that? Okay, so on this scale, can you see I've got like two big squares between here and here, but it spans 20 units. So that means each little square is going to be 2 then, isn't it? And I've got like 1, 2, 3 squares above 20. So I make that 26 then. So estimate the time when the current flow starts to decrease. It's going to be 26 minutes after which she started to charge, so after 10 a.m. then, isn't it? So it's going to be at 10:26 a.m. then. Okay. Use graph A and graph B to estimate the percentage charge in the phone when the current flow is 40%. So the current flow in is 40%. Where's that then? So on the graph, if I read across current flow from 40%, okay, let's switch pen. So I go 40% across to my graph there. And when I hit the curve, I'm going to start heading downwards. So what's that one then? That looks to me to be two little squares down from 40. So it's going to be at 40%. So after how many minutes? That's 36 minutes. Okay, so if we look up 36 minutes on the second graph then, until we hit the curve. So if we look up from 36 until we hit the curve there and read across, you see, I think we're at 80, aren't we? Okay, so then the charge time, the charge in the phone at 36 minutes, that's going to be 80%. Okay. Using graph B, estimate the rate of increase in the percentage charge when the phone has 90% charge. Okay, when does it have 90% charge? Charge in the phone has 90%. 90% is going to be halfway between 80 and 100. It's going to be there. I'm going to switch back to red because I haven't used red on this graph. So go across to my graph here. When I hit the curve, go down. I don't need to go down actually. I need to stop on that curve there. I want the rate of change. So I want the rate of change at that point there. So the rate of increase in the percentage change when the phone is 90% is going to be like the gradient of the tangent of the curve at that point. So I'm going to have to put the ruler up against my curve. So it just kind of touches the curve at that point. Okay, let's just draw a line on it. Now to find the gradient of this line, I just need to make a triangle. So I think I'm going to make a triangle going up to from 100% down to where it crosses the axes then. What's that about? Just below 60. So let's just do a little triangle here, and then we'll work out the change in y and the change in x at that point. Okay, so triangle going this way, triangle going this way. How big is that triangle in those two directions? Okay, so I want the gradient of this, so it's going to be change in y again divided by change in x. So the change in y then is going from 100 down to 1 square below 60. So that's to, so this one's spanning 20 in 5 jumps. Each one of those squares must be 4. So it's going from 100 down to 56. So that's a span of 44 in that direction. So y is going to be, changing y is going to be 44. And then changing x, it's going from 0 to 60. Okay, it's going from 0 to 60. So the change in x is going to be 60 units in that direction. Okay, so I'm going to get 44 divided by 60. So what is 44 divided by 60? 44 divided by 60. That's 11/15 or 0.73. So I'm going to round off to 0.73. Now what is that? So that is 0.7. They estimate the rate of increase in the percentage change. So it's 0.73% per minute, I guess. I'm just going to say it's percent per min. Okay. Now drawing a tangent is not an exact science, and it's, you know, the graph is quite weeny. So if you're getting a slightly different answer to mine, no worries. As long as you did the same thing, as long as you drew your tangent on and measured change in y divided by change in x at some point along that line, even if it comes out to be a different value, if you've done the same steps, you're going to get the answer right. They kind of look at your own diagram and your own measurements and just check you're doing the right thing. So top tip is just to make sure you're drawing these things on the diagram, because they do need to check that against your answer in order to award you the marks. Question 16. H is inversely proportional to the cube root of L. H is 7 when L is 64. Work out an equation connecting H and L. Okay, so with these, this here tells you how the two things are related to each other. So H is proportional to 1 over the cube root of L. Okay, so once we've written it like that with the symbol of proportionality in it, we can replace that symbol with equals K. So I get H equals K over the cube root of L like that. Okay, now with these questions, they always give us a kind of pair of handy values that go together, and they give you those so you can evaluate K basically. So I can say when H equals 7, L is equal to 64. So we can sub that into the equation, and so 7 is equal to K over the cube root of 64 then. Okay, subbing in for H and L. Now I know the cube root of 64 is equal to 4, so then cross multiplying, then I'm going to get K is equal to 4 lots of 7, isn't it? It's going to be 28. Okay, so therefore the equation linking H and L is H equals 28 divided by the cube root of L, like that. Okay, and then so work out the value of H when L is 2744. Well, that's fairly simple then. It's just about subbing that value of L into our formula. So 28 divided by the cube root of 2744. So it's a matter of tapping that into the calculator now. So 28 divided by the cube root of 2744. Oh, that comes out to be 2. Question 17. A, B, and C are points on the circle. Center O. BD is a tangent to the circle. OCD is a straight line. Work out the size of angle X. Okay. Now, in order to work this out, I'm going to have to apply various circle theorems to this diagram. Now, first up, I've been told that BD is a tangent to the circle. So that means that this line here, OB, which is a radius drawn at the point of contact, that needs to be at right angles to the tangent, because that is always a thing. So those two lines must always be at a right angle. Okay. Now, the second circle theorem that I can use is the fact that the angle at the center is twice the angle at the circumference, like that. So that angle there being 32, if I double it up, then I'm going to get the angle here, which must be 64. Okay, so that angle must be 64. So then I found two angles in this triangle down here then, haven't I? Okay, and I know that the angles in the triangle add up to 180 degrees, and I know the other two, so I should be able to find X. So I should know that X plus my 64 plus the 90, my three angles in the triangle, add up to 180 degrees. So if I add those two together, so that's X plus 154 is equal to 180. So taking 154 away from both sides, then X is going to be 26, then, isn't it? So that's my answer. X is 26. Question 18. Rearrange 9m plus 4 lots of 2m minus 1 equals p squared plus pm to make m the subject. Okay. So we've got m's appearing all over the place here. Now we need to get all the m's together in order to make m the subject. So let's see if we can do that. Let's start off by multiplying out this bracket here. Okay, so 9m plus 4 lots of 2m is 8m, and 4 lots of minus 1 is minus 4, and that's equal to p squared plus pm. Okay, now we want to move everything with m in it over to one side. Well, first off, I've got two terms there and I've got another one there, haven't I? I can add the 9m and the 8m together. That just gives me 17m. And then if I take the pm away to the other side, it's going to be minus pm. So 17m minus pm on the left. On the right, I'm going to leave the p squared, plus I'm going to move this term over to this side. So that minus 4 changes sign, it's going to become plus 4 on that side. Okay, so the pm moved over to the left and the minus 4 moved over to the right, and when they change sides, they change signs. Okay, so I've got 17m minus pm is equal to p squared plus 4. Now note I've got m here and I've got m here. I have a single m. If I want m is equal to something, I have to kind of squish these two terms together somehow. Okay, and the way I'm going to do that is I'm just going to factorize it out of these two terms. So if I write m at the front of a bracket like this, then I'm going to get 17 minus p inside the bracket there, taking the m out of those two terms and leaving what was left. The 17 and the minus p are going to go here and here, look. And then that is equal to p squared plus 4. And then all I have to do to get m, the subject now, is to divide through by that bracket then, isn't it? So then m is going to be p squared plus 4 divided by 17 minus p on the bottom like that. And that's it. That is my m. So not a lot of work for 4 marks actually. I think that was right. The trick to it here is factorising the m out. That's the bit you have to realise. So if you've got more than one term of the thing that you're trying to collect together, just kind of collect them all on one side and factorise the thing out that you want out of the bracket, and then divide through by what you've got left. Question 19. A circle has centre 0, 0 and passes through 0, 11. Write down the equation of the circle. Okay, so we've got a circle, and we're going to have some axes through that circle. So one in this direction, and one in this direction. And what do we know about circles? Well, what we know about this circle is we're told that that point there in the middle is the point 0, 0, and it passes through 0, 11. Now 0, 11 is up there, look, it's on the y-axis, so that's going to be 0, 11 up there. Okay, so what I know about this circle is I know its radius then, don't I? If it goes from 0, 0 to 0, 11 there, then the radius must be equal to 11. And I know that the equation of any circle that passes through the origin has the form x squared plus y squared equals r squared, and we've just worked out the radius is 11. So I know that then x squared plus y squared is equal to 11 squared. In other words, x squared plus y squared equals 121. Okay, I guess I should have written the answer on the answer line. So using a little bit of cheatery, let me just do that. Okay, so there we go. X squared plus y squared equals 121. Question 20. There should be a train leaving the station every hour from 7 AM. No trains leave early. The probability that the first train leaves on time is 0.9. For all other trains, if the previous train did leave on time, the probability that the train leaves on time is 0.8. And if the previous train did not leave on time, the probability that this train leaves on time is 0.65. So part A says work out the probability that the first 3 trains leave on time. Okay, right, so we know the probability of the first train leaving on time is 0.9. So probability that it leaves on time, time. Okay, so the probability that it leaves on time first off is going to be 0.9 for the first train. And then given that it did leave on time, the probability that all other trains leave on time is 0.8. And we're assuming then that it did. So 0.8 for the second train and 0.8 for the third train. Now we want on time and on time and on time, and as I said earlier, and means multiply, so we're going to have to multiply those three things together. So 0.9 times 0.8 times 0.8, that gives a probability that all three trains are on time are 0.576, so just a little bit over half. Okay, that seems about right for British Rail. Part B says the 2 p.m. train does not leave on time. Work out the probability that exactly one of the next two trains does not leave on time. Okay, so we know that the 2 p.m. train does not leave on time. So that means that the next train, the 3 p.m. train, has a probability of leaving on time of 0.65, isn't it? Because we know that the train before it did not leave on time. So the probability that the 3 p.m. train leaves on time is going to be 0.65, which means the probability that it doesn't leave on time is 0.35. Okay, so then that's the 3 p.m. train. Now the 4 p.m. train, that one is going to depend on where we are then. So assuming the 3 p.m. train left on time, then the 4 p.m. train has a 0.8% chance of being on time and a 0.2 chance of not being on time. So time, not on time. But if the 3 p.m. train was late, then the 4 p.m. train has got a probability of 0.65 of being on time, and then a probability of 0.35 of not being on time. Okay, so that's my tree diagram for this scenario. We want to work out the probability that exactly one of the next two trains does not leave on time. So then that's either going to be this route here, the probability of on time, not on time, probability of on time, not on time, or it could well be this one, not on time, time. Okay, so the 3 p.m. train is late, but the 4 p.m. train is on time. So that's the probability of not on time, isn't it? Okay, so the first one, the yellow route, that is going to be following the yellow route round. That's going to be the probability of 0.65 that 3 p.m. train is on time, times the probability of 0.2 that the 4 p.m. train is late, and then the other one is going to be not on time, 0.35 chance that the 3 p.m. train is late, times 0.65 that the 4 p.m. train is on time. Okay, so let's just work out what they are then. So 0.65 times 0.2, that comes to 0.13, and 0.35 times 0.65, that comes out to be 0.2275. Okay, now we want the probability of exactly one of those things. So probability exactly one, not on time, that's going to be those two things added together, isn't it? It's going to be probability of time, not on time, plus the probability of not on time, on time. So that's 0.13 plus 0.2275. So adding those two things together, add on 0.13 to my last answer, that comes out to be 0.3575. Question 21. Shape A is enlarged to shape B. 21A, circle the scale factor of the enlargement. Okay, so A is going to B. Okay, I think what I'm going to do is I'm actually going to answer part B first. I'm going to write down the coordinates of the center of enlargement first. And to do that, all I need to do is find matching points on object and image and join them with a straight line. So on my diagram here, this point here matches with this point down here, so I can join those together with a straight line. It's a nice and easy start. So, okay, then this one over here matches with that one over there. Okay, so joining those two together. And then finally, this point up here matches with that one down there. So if I join those two together, you should find that all your points converge on one spot. Well, actually that just goes through my other line, doesn't it? Okay, so they all kind of meet at one point, which is here, look, and that's going to be, oops, and that's going to be the center of enlargement there. Okay, so what is the center of enlargement? It is the coordinate 2 minus 1. So it's the coordinate 2 minus 1. So answering B first. Now to work out the scale factor, what you can do is you can measure the distance between your object and the center of enlargement and compare it to your distance from the center of enlargement to your image. So if you think about it, from this point down to here is kind of 2 diagonally squares going down, isn't it? Whereas on the other side there's 1. Okay, now I suppose it's 2 along, 2 down, and 1 along, 1 down, but basically the distance from A to the center is twice as big as the distance from the center to the image. And also the object and image are on opposite sides. That means that the scale factor is negative, so it's definitely not going to be those two. Okay, and the scale factor is going to be, well, it's actually getting smaller, isn't it? So it's going to have a fractional scale factor. So it's going to be this one here. It's going to be -1/2. Okay, so the scale factor is -1/2 because your image is getting smaller, so it's fractional, plus it's on the opposite side of the center of enlargement, so it's negative. So -1/2. Okay. Question 22. Simplify fully the fractions 2 over x plus 1 plus 7 minus 5x over 3 plus 4x. Give your answer as a single fraction. Okay. So I need to take those three things and find a common denominator. Okay, so I think what that common denominator is going to be is the denominators of the two fractions have been given. So it's going to be 3 lots of x plus 1 on the bottom. Okay. Now, how many times does x plus 1 go into 3 lots of x plus 1? It goes in 3 times. Okay, so you can see that this one here, look, fits here, so it's going to be 3 times bigger. So it's 3 lots of 2. So 3 times 2, because it goes in 3 times. Okay, plus 3 goes into 3 lots of x plus 1 times. So I'm going to get 7 minus 5x times by x plus 1, okay? Because I've got the 3 there, so in order to get 3 lots of x plus 1, I'm going to have to multiply it through by x plus 1. And then finally I've got 4x, but that's over 1, and I want to get it over 3 lots of x plus 1, so I need to multiply it through by 3 lots of x plus 1. So I'm going to get 3 lots of x plus 1 times by 4x. Okay, right, so then all I need to do now is kind of simplify the numerator a little bit. So 3 times 2, that's 6. 7 minus 5x times x plus 1. So I've got like double brackets here, so I'm going to have to kind of FOIL it, aren't I? So first, outside, inside, last. 7 times x is 7x. 7 times 1 is 7, minus 5x times x is minus 5x squared, minus 5x plus 1 is minus 5x. Okay, so that's the second part done. Next we've got 3 times x times 4x. So 3 times x is 3x times 4x, that's 12x squared. And then I've also got 3 times 1 times 4x. 3 times 1 is 3 times 4x is 12x. Okay, so that's 12x squared plus 12x from the last brackets. Okay, and that's all over 3 lots of x plus 1. Okay. Right, now the next step is to collect like terms together, isn't it? So what terms have I got? Well, I've got some terms in x squared. I've got 12x squared there and minus 5x squared there. I've got some terms in x. I've got a 12x, a minus 5x, and a 7x. And I've got some constants. I've got a 6, a 7, and that's it. Right, so collecting those together then. I've got the 12x squared and the minus 5x squared. That's going to give me 7x squared. Collecting the like terms in x, I've got 7x minus 5x, which is 2x plus 12x. That's 14x, so plus 14x. And then finally, I've got 6 plus 7, 13, isn't it? So my numerator simplifies to 7x squared plus 14x plus 13. Okay, now that's all over 3 lots of x plus 1. Now it'd be nice if that quadratic simplified to something with a term with x plus 1 in it, so I could cancel, but I don't think it's going to. Let's have a quick check. The coefficient of x squared is 7, so it's only got one factor pair, isn't it, because it's prime. So it's going to have to be 7x and x if it factorizes nicely. And the number on the end is 13. Again, it's prime. So if I was to get x plus 1 on the end, then the 13 must go here. That would give me 13 at the end. It would give me 7x squared at the beginning, but that gives me 13x and 7x, which is 20x in the middle. It doesn't match up. Does it factorize the other way around? If I put the 13 on this side, then I've got 7 times 13. That's like loads, isn't it? It's not going to come to 14x in the middle. Either way, it doesn't factorize, so I'm not going to be able to cancel it out with that x plus 1. Question 23. Alec makes a bowl for dog food from a solid wooden cone. The sketch shows how the bowl is made. The cone has a radius of 9 centimeters and perpendicular height of 30 centimeters. A smaller cone with a radius 6 centimeters is removed, so it kind of leaves a frustum at the bottom then. And the volume of the cone formula is given. Then a hemisphere with a radius of 6 centimeters is removed, leaving dog bowl. Okay, so work out the volume of the remaining wood that forms the bowl. Okay, so what we're going to have to do is work out area of big cone and little cone, take one away from the other, find frustum cone, and then work out the volume of the hemisphere and take that away as well. Okay, so I need 3 things. I need my volume 1, which is the big cone. I need volume 2, which is the small cone, and I need volume 3, which is the hemisphere. Okay, they're the 3 things that I want. So big V1 is the big cone, so it's like the bit on the bottom plus the bit that's cut off. I need to know both those things. Okay, so if I work those 3 things out, then I should then be able to form the bowl. So let's just work out V1 to start with. So V1 is a big cone, so the volume of a cone is 1/3 of pi times r squared h. Okay, that's a formula for a cone. Now, do we know the radius? Yes, we do. It's 9. Do we know the height? Yes, we do. It's 30. So that's really simple to work out. So it's going to be 1/3 pi r, which is 9. So 9 squared times h, which is 30. Okay? Now I'm going to leave all this in terms of pi. Otherwise, it's going to be a bit of a mare when I'm kind of working it all out. It'd be much easier to leave it as a multiple of pi as I go through. So I'm just going to work out 9 squared times 30 divided by, and that's equal to 810 pi. Okay, that one wasn't too bad. Now, volume 2, on the other hand, is going to be a little bit more of an issue because I haven't been given the height of it, do I? I've not been given the height. Okay, but you do know that these 2 shapes are what we call similar. They are similar volumes, aren't they? Okay, because the angle at the top is the same. It's all the same, isn't it? So they're similar shapes, so that means that their heights are going to be in the same ratio as their radiuses. So because this one is 9 and this one is 6, can you see what the scale factor is from there to there? What would I have to multiply 9 by to get 6? I think that the scale factor there is 2/3. If I take 9 and I divide it by 3 and I times it by 2, I'm going to get 6. So if I do the same thing with the heights, so from 30, if I divide that by 3 and times it by 2, I'm going to get 20, aren't I? So that's going to have a height of 20. Okay, so now I do know the radius and the height. I can work out small cone now. So that's going to be 1/3 times pi times 6 squared times h, which we found out to be 20. Okay, so equal cone is going to be 6 squared times 20 divided by 3, and that comes out to be 240. So that's going to be 240 lots of pi. Okay, and then finally I've got hemisphere, which is going to be volume 3. The volume of a hemisphere is 2/3 pi r cubed. Do we know the radius? Yes, we do. It's 6. So it's going to be 2/3 of pi times 6 cubed. So what's 6 cubed times 2 divided by 3? That's 144 apparently. So that is 144 pi. Okay. So then the volume of dog bowl is going to be the volume of our original cone minus the bit of the cone we threw away, which is V2, minus the hemispherical hole we made into the cone, which was V3. So it's going to be 810 pi minus 240 pi minus 144 pi. So what's that then? 810 minus 240 minus 144. That comes out to be 426 lots of pi. Right, so that's all my calculating done, so I can now actually evaluate it here. So I'm going to just multiply that through by pi times by pi. So that comes out to be 1338.3. I'm going to round it off to 3 significant figures. So that is, oh, that's pi there. So that's 1340 cubic centimeters, 3 significant figures. Question 24. On the same day, Kate buys a car for £14,000 and a painting for £5,000. The value of the car decreases by 35% in the first year and then 10% each year. The value of the painting increases by 4% each year. Show that the painting becomes worth more than the car during the 5th year. Okay, so we need to work out the value of the car and the painting in year 4 and in year 5. Okay, so for the car in year 4, so I'm going to use this triangle FOM. Stick your FOM on it, final original multiplier, to help me work this out. So my final amount is what I want to find, isn't it? The original amount is 14,000, and the multiplier, well, it's going to be a 35% decrease in the first year, so multiplier 1 is going to be 100% minus 35%, which is 65%, which is 0.65. So that's my first multiplier. So that's for year 1. And for year 2 and subsequent years, it's going to be a 10% decrease. So that's 100% minus 10%, which is 90%, which is 0.9 as a multiplier. Okay? So then my final amount is going to be my original times my multiplier. But I've got more than one multiplier to apply here. So my year 4 amount is going to be the original amount, 14,000, times the depreciation after year 1, which is 0.65, times my depreciation for the next 3 years, which is 0.9 cubed, isn't it? Okay, which is going to be 14,000 times 0.65 times 0.9 to the power of 3. Okay, so that comes out to be 6,633.9. 6,633.9. That's in pounds, I guess. So, okay, and then in year 5, it's going to be another 0.9 multiplied onto that then. So times that by about another 0.9. That comes out to be 5,970.51. Okay, so that's in the year 4 and year 5 cost for the car. Now for the painting, That's increasing in value as time goes on, isn't it? So final, original, multiplier. Final is what we're finding. Original is the £5,000 value of the painting, and the multiplier, it's increasing by 4% each year. So it's going to be 100% plus 4%, which is 104%, which is 1.04 as a multiplier. Okay, so then my final, again, is going to be original times multiplier. So for year 4, that's going to be the £5,000 times 1.04 raised to the power of 4, then, isn't it? It's going to be 4 years increasing at 4%. So that comes out to be 5,000 times 1.04 to the power of 4. That's 5849. So at year 4, the car is still worth a bit more. 5849. I'm just going to round it off to 5849. Okay, and then in year 5, it's going to be, well, it's going to be 5,000 times 1.04 to the power of 5. That's going to be times it, or take my last answer and times it by another 1.04. That comes out to be 6083. 6083. So you can see now then it's increased beyond the price of the car, because the car is now 5970 and now the year 5 price is 6083. So I can therefore say painting worth less end of year 4 and more end of year 5. Question 25. Two sides of the triangle are measured to 1 decimal place. The angle between the sides is measured to the nearest degree. Work out the upper bound for the area of the triangle. Okay, so let's say that this is a triangle CAB. So then that is side A and that is side B, and the area of the triangle then is going to be, using the trigonometry formula, it's going to be half AB sine C, isn't it? That's the formula we're going to be using. Okay, but before we use those, we need to work out what our upper and lower bound are for the three lengths A, B, and the angle C. Okay, so let's start with A and B. Now these sides were given to the nearest decimal place. Okay, so what I like to do with these questions is I draw a quick number line. I mark on the value been given. So for A, we're told it was 13.6 to the nearest decimal point. So the next one up on the scale would be 13.7, and the one below would be 13.5. So the values that round to 13.6, they're going to be the ones that are kind of halfway between those two or nearer. These are the ones that round to 13.6. So that's going to be 13.55. That's the lower bound, and 13.65 is the upper bound. Okay, so that's the upper bound and lower bound for A. Now B is going to be similar. We've been given it as 7.2. On the number line, 1 decimal point above that would be 7.3, and one below it would be 7.1. So the halfway values are going to be 7.15 and 7.25. Okay, so that's the range of values for B. And then finally for angle C, that is to the nearest degree, and we've been given it as 110. So 1 degree above would be 111, and 1 degree below would be 109. So the ones that round to 110 are going to be halfway between those or nearer, which is 109.5 and 110.5. Okay. Now, obviously, I want to work out what the upper bound is. So I'm definitely going to need the largest value of A and the largest value of B. That's for certain. I'm not quite sure about the sign, because the sign goes up and down in value. So I think I'm going to work out both values using both my endpoints. I'm going to use this one and I'm going to use this one because I'm not quite sure what the effect that the sine is going to have. So I'm going to work out both, and then I can see what's what. But I'm definitely going to use the bigger one for A and B because it's just a straight multiplication for those. So the bigger value of A and the bigger value for B is going to be my bigger value for my area. Okay, so area could be a half times the upper bound, which is 13.65 of A, times the upper bound of B, which is 7.25, times the sine. Well, I don't know. I'm going to try the upper bound, 110.5, and then see what that gives me. And then I'm going to do the same thing. I'm going to work out half 13.65 times 7.25 times the sine of 109.5, and I'm going to see which is the bigger one of those two, and then that is going to be my my answer, and that's going to be my upper bound, isn't it? So let's work those two out. So 0.5 times 13.65 times 7.25 times the sine of 110.5. Now that one comes out to be 46.347. I'm going to round it off to 46.35. Okay, and then the other one, 0.5 times 13.65 times 7.25 times the sine of 109.5. I got a feeling that one's going to be bigger. Yeah, it is 46.64. So spookily, the smaller angle of the two actually delivers the biggest result in it, and it's because the sine goes up and down like this, isn't it? Okay, so you know, just because the angle is bigger doesn't mean that the sine of the angle is bigger, because it oscillates. Okay, so in this case, the sine of the angle ends up being smaller the bigger it is in that range. So yeah, so therefore my upper bound is going to be the bigger one of those two, then, isn't it? It's going to be that one there. Is 46.64. Question 26. Here is the sketch of the graph y equals 5 to the power of x. So that's an exponential curve, isn't it? In parts A and B, the sketch of y equals 5 to the power of x is shown as the dashed line. That's handy. On the axes below, sketch the graph of y equals minus 5 to the power of x. Okay, so what's happened here to this graph? I had f of x, and it's gone to f minus f of x, isn't it? I've got a minus sign in front of the function. This was the original function. I've now got the same thing but with a minus sign in front of it. Okay, so it's a minus sign in front of the function. So what is this? This is a reflection. This is a reflection in the x-axis. Okay, now there's a whole bunch of these that you need to know. Okay, I'll just pull up a table of all of them. You can see that f of x goes to f of minus f of x. In this table, it shows that it's a reflection in the x-axis. You just have to kind of learn them. There's 6 of them you need to know altogether. 2 reflections, 2 stretches, 2 translations. Okay, you need to know which way around they go. This one is a reflection in the x-axis, so all I need to do is reflect this one in the x-axis. So when I draw my sketch, it's going to have to look the same like that. Okay, doesn't have to be a work of art, just roughly symmetrical around the line like that. Now part B, I've got y equals f of x becomes y equals f of x minus 1. So this is f of x goes to f of x plus k, isn't it? I have my original function f of x, my original function of f of x, and I am adding to it, I'm adding k to it, in which case k is minus 1. In this case, I'm adding a negative value. So that is a translation. That is a translation of k units up. Now in this case, I've got a minus 1. So negative 1 units up is a translation of 1 unit down. Okay, so it's a translation of 1 unit down. Now that point there is the point 0, 1, isn't it? Because always your exponential curves pass through the point 0, 1. because anything to the power 0 is 1. So then if I move that 1 unit down, it's going to go there. It's going to pass through the origin. Okay, so what I'm going to get is a graph that looks like this. It's going to match the graph above, but it's going to pass through the origin. Okay, like that. Okay, so as long as it vaguely follows the graph above and it passes through the origin, you should get the mark for that. So I just put that as the point 0, 1 and that as the point 0, 0, so it's clear that I knew where the point went. And that's it. That's my paper done. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.